Chi-squared video 2. This is a continuation of chi-squared test for association or independence. This is going to be the practice portion. So we're going to talk about some AP questions related to chi-squared test for association independence. This is the most common chi-squared test. So as you can see, I was up to this part where I got my p-value and I got my chi-squared value and I was ready to make my conclusion. If you remember, my p-value is 0.001 because that was less than 0.05. It is statistically significant at the alpha equals 0.05 level. So I rejected my null hypothesis and I included in favor of the alternative hypothesis, which said that there was indeed an association between the music type played and the entree order. Please note that it says AP exam tip. In the do step, you aren't required to show every term in the chi-square test statistic. Writing out a few more with a little plus sign, a little dot, dot, dot is enough work. So that's what I showed you up above. Now, I do want to mention how to get the degrees of freedom. We only have to get the degrees of freedom on the calculator. In this case, it's right here. Degrees of freedom equals 4. But there is a way to get the degrees of freedom by hand. And the way to do it is you get the number of rows minus 1 times the number of columns minus 1 without totals. So if you remember back to my question, here was my matrix. This was 3 rows and 3 columns. 3 rows and 3 columns without the totals, 3 by 3. So if I wanted to find the degrees of freedom by hand, I would have done 3 rows minus 1 times 3 columns minus 1, or 2 times 2, which is 4. And that actually is the degrees of freedom that the calculator says, degrees of freedom 4. So that's how we get it by hand, row minus 1 times column minus 1. That did show up in one multiple choice ever on the AP, as you had to do it by hand. All right, moving on. You can use your calculator to carry out the mechanics of the significance test, but there's a risk involved if you just give the calculator answer without showing your work and one or more of your entries is incorrect, so meaning you pressed like the wrong button, you made a little boo-boo putting a number in, you'll likely get no credit for the do step. We recommend writing out the first few terms of the chi-square test followed by the dot, 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 like I just said. This approach may help you earn partial credit if you enter a number incorrectly, all right? Moving on. All right, so here's another example. Are people who are prone to sudden anger more likely to develop heart disease? So basically, is there a relationship between people who experience sudden anger and heart disease? They did an observational study. So remember, this is not an experiment if they did an observational study. So they can't really conclude causation. They can only conclude correlation of 8,474 people with regular blood pressure. Each person took this test and they recorded whether each individual developed this heart disease. Do these data provide convincing evidence of an association between the variables? So the key words that you're going to look for, people, are either the word association or independence, and that's how you know it's a chi-square test for association / independence. Okay, so let's quickly review what we did before. So the null hypothesis is going to be a statement of no change. So you're going to write there is no relationship or there is no association between anger level and CHD status, meaning that the two variables are independent of each other. I would rather you write no association or association because if you write one dependent on the other, you have to know which one is the dependent variable and which one is the independent variable. So it's kind of better to just write there's no association and there is an association. There is an association between anger level and CHD status. Okay. So now remember, we would want, oh, I guess the null and the alternative hypothesis should have gone there, down below, whatever, it's okay. So now what we're going to do is we're going to enter our data in the matrix again, right? So here we go. We're going to press second x to the -1, and we're going to go to edit, and we're going to hit enter on matrix 1. So notice here again, it looks like we have a 2 by 3 matrix because we have 2 rows for CHD status and 3 columns. So this is a 2 by 3 matrix. Okay. So when we go to our calculator, we're going to do edit for matrix A. You're going to hit 2 by 3, hitting enter on the number 2 and 3, and it will change your matrix. Then you're going to put in the yes column first, yes row, sorry, 53, 110, and 27, and then the no, 3057, 4621, and 606. Okay, so now once we make sure that our observed counts are in correctly, we do want to label these observed counts, observed or actual counts, right? So now we're going to run our chi-square test. So to run the chi-square test, we press stat, we go over to test, and we go up or down until we get to letter C for Cowabunga, chi-square test, and you're going to do observed A, expected B, calculate. Now remember, we don't really care yet about the chi-square test statistic and the p-value. Instead, we have to go back and copy down our expected counts, which are going to be located now in matrix B. So we press second, x to the negative 1. You could choose number 2, or again, you could go to edit and go down to matrix B, and now matrix B will be different, and those are going to be your expected counts. So in this case, maybe I'll make it a separate expected counts table, and I'll just kind of drag and drop them for you for the sake of time. Okay. So now we have our observed counts and we have our expected counts. Now, when we're doing phantoms, we need to do make sure that all of our expected counts are greater than 1 and greater than 5. So if you look here, it says all expected counts, they are greater than 1 and they are greater than 5. This is met. That's good. And then also we want to check if it's a simple random sample. It said it was an observational study done on a random sample. So it was a random sample selected. That's good. Assume that it's a simple random sample taken from the population of interest. All right. So now we are done with our, we didn't really need to write our population of interest, by the way. It's probably all normal people with normal blood pressure. But we don't really need to write it. Population, we done, H done, A done. Now we go to the name. So the name is a chi-square test for association or independence. And again, if you want, you could just write chi-square test. Now we're going to go to our test statistic. Test statistic formula is on the reference sheet. Remember, it is chi-squared, big X squared equals summation, which means you're going to add them all up of observed minus expected squared over expected. Remember, you don't have to memorize that. It's on the formula sheet. So now we're going to do the first term and then a plus sign, a dot, 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 and the last term. So starting with the top left, we're going to do yes and low. Yes and low. Okay, so the observed was the 53. The expected was 69.731. Squared over expected, 69.731. Now you're going to do a plus sign and a little dot, dot, dot. Then you're going to do the last term, which I'm going to do on the bottom right. That's going to be no high. So the observed was 606. The expected was 618.81 squared over expected, 618.81. Okay, so we kind of know the mechanics behind this now, and now we're ready to write our chi-square test statistic down. So let's go back to our calculator and let's run our test again. So again, you're going to press stat, go back to test, go up or down till you get to letter C, and you're going to go to calculate or draw. If you want, you could choose draw, or you could choose nothing. And you could see actually what the shape of the chi-square test is, which is going to be skewed right. And the reason why it's skewed right is because everything is squared. So everything's going to be positive. It's not going to be like the z-score, which has positive and negative values. It's just going to be positive values. So you see the chi-square test statistic is here on the bottom, 16.0768. So that would be if I had added up all of my chi-square test statistics, it would have equaled that. And then the p-value is also a very small number. It is 3 times 10 to the negative 4th power, which is 0.0003. So this is really tiny, and actually it's approximately 0. So now we know we can make our conclusion and make our decision. So the M step of phantoms is make a decision. So because my p-value of 0.003 is less than alpha equals 0.05, and actually even smaller alpha level of 0.01, I can reject the null hypothesis. So that's my decision. And then my sentence for my conclusion is thus, I can conclude there is an association between anger level and heart problems, heart disease. So indeed, they are related, and that means that anger really can influence your heart. So there you go. That was the second question. As you can see, I kind of sped it up and did a little bit faster on this one. But now let's see how it plays a role in the multiple choice. Okay, so I'm going to kind of skip through here. Again, you see the word association. Let's go to multiple choice. This is the AP question. A group of men and women were surveyed to investigate the association. So I would circle the word association between gender and the number of friends they have on social media. Results are shown below. So here we have a two-way table. Notice we have 2 rows and we have 1, 2, 3, 4, 5 columns. So this is a 2x5 matrix. And notice it's categorical variables because it's gender and the number of friends are put into categories. Which of the following procedures is the most appropriate way for investigating whether an association exists between gender and the number of friends? So as soon as you guys see that keyword association, you know it's chi-square test for association, because that keyword association means there's an association. So you're going to choose the one that says chi-squared test. But oh no, wait a minute, we don't have chi-squared test for association because that would be too obvious. So you have to choose letter E, chi-squared test for independence, because remember, the chi-squared test for association could also be called the chi-squared test for independence. This means, is there a relationship between gender and number of friends on social media? Are they independent of each other, or is there a relationship, meaning dependent? That's that one. Next one. Allie surveyed 200 students at the school and recorded their eye color and their gender. Of the 80 males, 60 had brown eyes. So of the 80 males, 60 had brown eyes. If eye color and gender are independent, meaning there's no relationship between the two, how many female students surveyed would be expected to have brown eyes? All right, so females, there were, I'm guessing we have to do 200 total minus 80. It's going to be 120 females. So remember, if there's no relationship between the two, that should mean that females and males would have the same ratio of brown-eyed people, because it basically won't matter if they're a male or a female. The percent of brown-eyed people will be the same. So this actually relates to the conditional probability that we did earlier in the year. Given that someone is a male, the probability that they have brown eyes should be equal to, given that someone is a female, the probability that they have brown eyes. It shouldn't matter if you're a male or a female. If the events are independent, then knowing that their gender is male or female won't impact if they have brown eyes or not. So we also related this to a segmented bar graph earlier in the year when we had gender on the x-axis and we had male and female. If you remember, the segmented bar graph went up to 100%. And then there was a breakdown within those percents based on whatever variable we're measuring. So let's say it was brown eyes. What I would do is I would calculate the percent of men who have brown eyes. That's 75%. I should have known that. But basically, I would want the percent of females to be the same, 75%, in order for this to be independent. So if I were to sketch this out, 75% would be the segment breakdown for males and females going across the segmented bar graph, which would mean that it doesn't matter if you're a male or a female, the percent of the gender that have brown eyes will be the same regardless. So we're going to do 75% of 120 now to find the numerator of our fraction. So we're going to do 0.75 times 120, and we got 90. So this should be 90 females out of 120, and that would give you the same percent breakdown, meaning that it's the eye color is independent of the gender. There's no relationship between males and females and their eye color. Next one. Okay, here we have another two-way table. It says we have a random sample total of 275. Notice that's not here. So on the bottom right, we would want to put in 275. That's going to be our total. It says which of the following procedures would be the most appropriate use of investigating if there is a relationship between vehicle type and eye color. So again, these are two categorical variables. The two variables that are putting people into categories in this case are their vehicle type, which is car or truck, and then their vehicle color. So when we're dealing with association or relationships, when we're dealing with two categorical variables, we're looking for the chi-square test for association. If that's not there, you have to choose the one that says chi-square test for association independence. So here's the independence one. So is the car type independent of the color or not? That's that. Okay, looks like that's it for now. I think I have some more, but maybe I'll make another video. So there you have it. If you get one of these, I have to say, if you understand these, they're actually easier than the two proportion z-test pooled because there's way less work, less to check, less assumptions to check, less of everything. So it's kind of nice if you learn this from this video. You're welcome.